The objective of this lesson is to solve mixed number subtraction problems. In previous lessons, students have subtracted fractions less than 1. In today's lesson, students will extend their knowledge to fractions greater than 1. They will explore multiple ways to subtract mixed numbers. Let's begin with our first problem. Lauren had 1 5/6 packages of pasta in her pantry. She used 4/6 of a package in recipe she made for dinner. How many packages of pasta does Lauren have now? The equation to represent this problem situation would be the minuend, 1 5/6 packages of pasta she started with, minus the subtrahend, the 4/6 she used, equals the difference. Let's use the letter P to represent the difference. Let's model this problem. Start by drawing two rectangles. There will need to be two rectangles because there is one whole package of pasta and another part of a whole, 5/6. Color in the first rectangle completely to represent the one whole. Then divide the second rectangle into 6 and color in 5 parts to represent the 5/6 of a whole started with. The problem states she used 4/6 of the starting amount. This means she subtracted 4/6 from the starting amount of 1 5/6. This is shown by crossing out 4 of the 1/6 size shaded pieces. The difference is shown by the shaded pieces that are not crossed out. There is one whole and 1/6 piece not crossed out. Lauren has 1 1/6 packages left. Now let's represent the problem numerically. Start by subtracting the fractional pieces first. 5/6 minus 4/6 equals 1/6. 1 whole minus nothing is 1 whole. P equals 1 1/6 pasta packages left. Let's look at another problem where the subtrahend has a larger fractional piece than the minuend. Lind has 1 1/4 bottles of water in his backpack. During track practice, he drank 3/4 of a bottle. How much water does he have left? The equation to represent this problem would be 1 1/4 bottles of water he started with, minus the 3/4 of a bottle he drank, equals W, the amount of water still left. Let's model the problem using pattern blocks. Start by placing a whole yellow hexagon and 1/4 of a hexagon. Start by subtracting the fractional pieces. The problem states to take away 3/4. There is only 1/4 fractional piece to take away from. In order to subtract the 3/4, the whole must be decomposed into 4th-sized pieces. One whole is equivalent to 4/4. The equation would now read 4/4 plus the 1/4 fractional piece minus 3/4 equals W. One way to subtract would be to take the subtrahend of 3/4 away from the whole in the minuend. This is shown on the model by removing 3 of the 1/4 size pieces from the whole. Numerically, the equation would read 4/4 minus 3/4 in parentheses plus 1/4 equals W. There is 1/4 left from the whole plus the 1/4 initial fractional piece for a total of 2/4. W equals 2/4 of a water bottle left. Another way to solve the problem would be to rename the minuend. Start by decomposing the one whole into 4/4. The equation will read 4/4 plus 1/4 minus 3/4 equals W. Combine the 4/4 and the fractional piece of 1/4 for 5/4. The equation would now read 5/4 minus 3/4 equals W. Subtract the 3/4 Lynn drank. There is 2/4 of a water bottle left to drink. The objective for this lesson was to solve mixed number subtraction problems. We met this objective by solving real-world problems. We decomposed the fractions both visually and numerically to subtract mixed numbers.